Hello, hello. We are going to do some practice problems on intervals of increase and decrease. So let's get started. Our first thing here is intervals of increase and decrease on a square root function with a lead coefficient of x. I guess that wouldn't be a coefficient, it'd be a variable. But basically, what I'm getting at is this isn't just a polynomial. So there's a little bit more that's going to go on as we do this example. So if I want to find the intervals of increase and decrease and or classify all local extrema, I really need to find the critical points first. I need to find where f prime equals 0 or doesn't exist. So I'm going to find f prime of x, and that's going to be a product rule with a chain rule. So I have the first times the derivative of the second plus the second times the derivative of the first. And I need to know when this equals 0 or doesn't exist. Now, when I'm taking derivatives and eventually antiderivatives, I don't like fractions, I don't like exponents. But when I'm solving equations, I like fractions, I like exponents. So I'm going to try to rewrite this in a way that's easier to solve for me. So 1/2 times -2 is -1. So this would be negative x squared over the square root of 4 minus x squared. Plus over here, I'd have the square root of 4 minus x squared over 1 equals 0. In order to solve that, I am going to add the fraction part to both sides. And then I am going to multiply both sides by that radical. Now, I'm doing a lot of algebra really fast. But basically what I'm trying to do is I'm trying to solve for x. I'm trying to get x alone. So the easiest way for me to do that is either to get a common denominator, but then that would be a radical, and I don't want to do that, or eliminate the fact that there's a denominator, and that's the route I'm taking. So now I have 4 minus x squared equals x squared, which means 4 equals 2x squared. Divide by 2 and square root it. X is plus or minus the square root of 2. But that's the answer for where the derivative equals 0. I need to know when the derivative equals 0 or where the derivative doesn't exist. So now I'm going to look back at this derivative and say, well, fractions don't exist when the denominator equals 0, and that would be when x equals plus or minus 2. Now, technically, this denominator also does not exist when the square root is negative inside, but I'm going to take care of that with the domain in a moment. Okay, so now I found 4 critical values, plus or minus root 2 and plus or minus 2. So now I need to use those critical values to set up intervals of increase and decrease. So if I want to do that, I'm going to move my face over here. If I want to find my intervals of increase and decrease, what I would want to do here is think about my domain of the original. Well, the original, x isn't really a problem, but that square root of 4 minus x squared is. I need 4 minus x squared to be greater than or equal to 0. Now, honestly, for me, the easiest way to solve that is I can think of what 4 minus x squared looks like as a graph. The graph of 4 minus x squared is an upside-down parabola hitting at plus or minus 2, and that is above the x-axis in between the roots. So the domain of our original function is -2 to 2. So when I go to rate my intervals of increase and decrease, I'm going to start and end -2 and 2. So my intervals of increase and decrease are going to go from -2 to negative root 2, negative root 2 to root 2, and root 2 to 2. 1, 2, 3, 4. Yeah, that looks good. Okay. Now I need to decide whether my derivative is positive or negative on those intervals. So now I am going to find f prime of a number between -2 and negative root 2. Okay, well, that's a little bit tougher. So you know what? I'm just going to choose like -1.9 and see what we can do in our head here. So if I have -1.9, all I care about is the sign of what's in that blob there at -1.9. Well, this numerator is going to be negative. This denominator is going to be positive because it's a positive square root, and this is going to be positive. So if I pick negative 1.9, my denominator is going to be really close to 0. My numerator is going to be very close to negative 4. Negative 4 divided by a number close to 0 is going to be negative much bigger than 4, right? Because like negative 4 divided by 0.01 would be negative 400. And then I'm adding a number close to 0. That thing's going to be negative. All right. I don't want to spend time in this video explaining all the nuances of that numerical thinking. So if you need help with that, come and see me. I'm happy to talk it through, but I don't want to do that in the video. So f prime is less than 0 there, which means f is decreasing. Oh, thank heavens. From negative root 2 to positive root 2, we should test f prime as 0. So that's going to be 0 over root 4 plus the square root of 4. That's positive. So f is increasing. And from root 2 to 2, I can test 1.9, which, since all my x's are squared, acts just like negative 1.9. So that's going to be less than 0, and f is decreasing. Now, that means f goes down and comes back up and then goes down again, which means we have a minimum at negative 2, and we have a negative root 2, pardon me, and we have a maximum at positive root 2. So that means that we're going to come up here because I'm running out of room. At negative root 2 comma something, we have a relative or we have a local min. And at positive root 2 something, we have a local or relative max. Now, what is the something? Well, if I put negative root 2 in here, f of negative root 2 would be negative root 2 times the square root of 4 minus 2. That's going to be negative 2. And if I make that positive root 2, I'll just get regular 2. So we have a local min at negative root 2 comma negative 2, and a local max at root 2, 2. And there are my classified coordinates of the local extrema across its entire domain. All right. Down here, classify the coordinates of all local extrema of g of x equals x squared times e to the x using the first derivative test on its entire domain. The first derivative test is just the idea that we are testing within the first derivative on those intervals. All right, well, let's see. Entire domain, while I'm thinking about it, I can square anything. I can raise e to anything. So our entire domain here is negative infinity to infinity, so that's not an issue. And if I want local extrema, I need critical points. So I want to know when g prime of x equals 0 or doesn't exist. So the first times the derivative of the second, plus the second times the derivative of the first. I want to know when that equals 0 or doesn't exist. And there's no fractions, there's no logs, there's no radicals. So this exists everywhere. Going to ignore that. When does it equal 0? Well, I could factor out an x, and I can factor out an e to the x, which would leave me with x plus 2. So x equals 0, e to the x equals 0, x plus 2 could equal 0. Because when you have a product of things and that product equals 0, the zero product property says that one of the things was a 0 in the first place. So x equals 0, there's a good critical point. E to the x equals 0. Yeah, never. That's not going to happen. X plus 2 equals 0 when x is negative 2. So my two critical values are 0 and negative 2. My domain is negative infinity to infinity. So from negative infinity to 0, 0. Oh, wait, no. Negative 2 comes before 0. There we go. Fixed it. Here are my three intervals of increase and or decrease. And now I need to figure out g prime at each of those places. G prime of, let's say, negative 3. Now, I could plug negative 3 into here to find G prime, or better yet, I could plug -3 into here. I'm going to do that second one. Let's see if I can erase. I did it. So when I plug -3 into the second one, that's my better option because I don't need to know the value. I just need to know the sign because I'm multiplying. -3 times e to the -3. Well, e to the anything's positive. So I have a negative times a positive. -3 plus 2 is negative. A negative times a negative is positive. G prime of 3 is greater than 0. G prime of, -3 is greater than 0. So G is increasing. From -2 to 0, let's find G prime and -1. A negative times a positive is negative. So G is decreasing. And G of 1 would be positive times positive times positive. So G prime of 1 is greater than 0, meaning G is increasing. So G increased, and then it decreased, and then it increased. So we have a maximum here and a minimum there. So I now know -2 comma something is a relative or local max, and 0 comma something is a local min. I forgot to write that. Local or relative, doesn't matter. I'm using both words interchangeably. And when I plug -2 into the original to get my y value, that's going to be 4 over e squared and 0. There's my local extreme values. Okay, I have one more left to do. So what I'm going to do with this one is I'm going to say, you know what? I got to take the derivative. I don't want to do the quotient rule. So I'm going to take h and I'm going to divide it. Whoops. I'm going to divide it before I find h prime. If I divide all that stuff by x, I get x minus 5 plus 6x to the -1. And that derivative is easier to take than the quotient rule. Go me. So now that I have the function written in plus and minus form and not fraction form, my derivative is just a power rule. So h prime is 1 minus 6x to the -2. I want to know when that equals 0 or doesn't exist. So that's 1 minus 6 over x squared. I can already tell this doesn't exist at x equals 0. And when I look at this, 1 minus 6 over x squared equals 0 when x is plus or minus radical 6. And if you're thinking, how'd you do that so fast? I said, well, 1 minus 1 is 0. A fraction equals 1 when the top equals the bottom. So x has to be plus or minus root 6. So I have 3 critical values. And now I need to think about the domain. The domain of this thing is everything except 0. And I'm already going to break my domain at 0. Sweet. So then my intervals go from -infinity to -√6. -√6 to 0, 0 to √6, and √6 to infinity. All right, h prime. I'm going to probably use this to evaluate h prime. So h prime of, let's say, like -10, that's going to be 1 minus 6/100ths. Yeah, that's positive. So h is increasing. Between -√6 and 0, how will we do h prime and -1? That's 1 minus 6 over 1. That's going to be negative. So h is decreasing. From 0 to √6, I'm going to do h prime of 1. 1 minus 6 over 1, still negative. H is still decreasing. And from √6 to infinity, h prime of, let's say, 10, that is going to be greater than 0. H is increasing. So h increases and then decreases and then decreases and increases. That's going to be a maximum. This is going to be a minimum. So at the point -√6 something, we have a local max. And at √6 comma something, we have a local min. And what is the something? Ooh, it's kind of gross. So let's see. Negative root 6 squared minus 5 times root 6 plus 6. Yikes. Well, I'm just going to write it in its kind of nasty looking form here. That's going to be 12 plus 5 root 6 over root 6. I'll live with it. And then that's going to be 12 minus 5 root 6 over root 6. Yucky, but true. So that is the end of this. I hope everybody is having an excellent day. My kids keep telling me that my jokes are terrible, so I'm just not going to tell you a joke today. I hope you have a good day. What else can I tell you? I don't know. Right now, my favorite color is green. There's a random fact, and I can't wink. Strange, but true. Can't wink. Have a great day, everybody.